On the evening of May 4, 2026, the harbor gates open. A colossal concrete structure, longer than 2 football fields, slowly emerges. Built entirely of concrete, this giant weighs tens of thousands of tons. Yet, it does not sink. It floats gracefully on water. 5 tugboats slowly maneuver the massive hull toward the Baltic Sea. Special pontoon barges are secured to both sides of the element. Inside, temporary ballast has already been installed for stability. In a few hours, this structure will be lowered to the bottom. Ahead lies the dredged trench and the Danish portal of the tunnel. No crane on Earth can simply lift and place this section. It will rest on the seabed, carrying vehicles and trains safely. The Fehmarnbelt Strait separates Denmark from northern Germany. Currently, travelers rely on ferries to cross this marine gap. The ferry crossing takes about 45 minutes, excluding wait times. The new tunnel will revolutionize travel between Scandinavia and Europe. It will cut travel time to just 10 minutes by car. And the train journey will take only 7 minutes. For a long time, engineers considered building a bridge. But a bridge required massive pillars in deep shipping lanes. And traffic would be vulnerable to strong Baltic winds. A deep-bored tunnel was also evaluated as an option. But the complex geology made boring extremely risky and expensive. In 2011, the Immersed tunnel design was officially chosen. This shifted the challenge to mass production on land. A massive industrial city was built on Lolland's coast. The facility covers about 1.5 million square meters. It features 5 standard and 1 special production lines. Robots and workers assemble the massive steel reinforcement cages. Each standard element is 217 meters long. They are cast in 9 sequential segments, not all at once. Precision is critical. Each segment must fit perfectly. Concrete is poured under strictly controlled temperature and speed. As one segment cures, the element is pushed forward. The process resembles shipbuilding on a massive scale. Temporary steel bulkheads seal the open ends of elements. The dry dock is flooded to make elements float. At the calculated moment, the element lifts off supports. Tugboats guide the floating giant into the harbor. Surveyors verify the element's position and alignment constantly. Sensors monitor the heat generated by curing concrete. Laboratories test concrete samples to ensure maximum strength. A massive rubber seal is installed on the end. Meanwhile, dredgers prepare the trench in the strait. They excavated about 15 million cubic meters of soil. A leveled gravel bed is laid in the trench. Robotic crawlers verify the flatness of the gravel. On May 4, 2026, the first element departs. 5 tugboats tow it to the portal site. Winches and cables on the pontoons control movement. Operators monitor wind and currents in real time. The working area is marked with safety buoys. Ballast tanks are flooded to begin the immersion. The element slowly sinks beneath the waves. The descent is controlled with millimeter precision. Underwater cameras and sensors guide the final touch. The element lands safely on the gravel bed. Hydraulic jacks pull the element toward the portal. The rubber seal compresses, forming a tight joint. Water between the bulkheads is pumped out completely. Hydrostatic pressure pushes the element tightly together.
A permanent secondary seal is installed from inside.
Engineers verify the joint's tightness and geometry. The temporary bulkheads are removed, opening passage. The first section is now part of the tunnel. In June 2026, the second element departs. 2 separately cast elements must be aligned underwater. By late June, over 500 meters are underwater. Gravel and stones are deposited to secure sections. A protective stone layer shields the concrete structure. This protects the tunnel from anchors and collisions. Work also proceeds from the German side, Fehmarn. Elements will meet in the middle of the strait. Each element contains 5 separate longitudinal tubes. 2 tubes are dedicated to road traffic lanes. Two tubes carry high-speed railway tracks. A central gallery serves for service, and evacuation. Asphalt is paved inside the road tubes. Railway tracks and power lines are installed next. Ventilation, lighting, and safety systems are added. Emergency systems are tested thoroughly before opening.
Fire safety and smoke extraction tests are conducted.
Evacuation procedures are practiced with test groups. The tunnel will provide a fast, reliable link. Connecting Scandinavia and Central Europe like never before. A triumph of modern engineering beneath the sea. Environmental monitoring is conducted continuously throughout construction.
Scientists monitor water turbidity to protect marine life. Special measures protect local marine mammals, like porpoises.
Bubble curtains are deployed to reduce underwater noise. Coastal habitats are carefully preserved and monitored.
Danish and German authorities coordinate environmental compliance.
Real-time data is shared transparently with the public. The project is funded through state-guaranteed loans and supported by significant European Union subsidies. Toll revenues will repay the construction costs over time. Connecting Copenhagen and Hamburg directly will boost trade. Freight transport times across Europe will be reduced,
creating thousands of jobs and boosting local economies.
10 special elements are built for maintenance systems. These elements feature a basement level for equipment,
housing drainage pumps, transformers, and ventilation controls.
ensuring the tunnel remain dry and safe always. Casting these complex structures requires specialized molds. The two construction lines will meet in the middle. The final closing joint is custom-made for precision.
Actual measurements determine the final joint's parameters.
It cannot be adjusted after installation, requiring perfection. The entire 18-kilometer tunnel is finally connected. Laying the high-strength concrete road deck begins. Installing the ballastless track system for high-speed trains. Mounting the overhead catenary system for electric power. Running thousands of kilometers of power and communication cables. Installing the drainage system to handle any condensation. Installing fire protection boards on the concrete walls. Mounting the high-pressure water mist firefighting system.
Installing emergency phones, cameras, and public address speakers.
Setting up the traffic control center with automated detection.
Testing the massive ventilation fans that can reverse airflow.
Running test trains through the tunnel at increasing speeds. Conducting emergency drills with local fire brigades and police. Simulating various accident scenarios to test response times. Please keep moving straight ahead into the gallery.
Verifying communication systems between Danish and German dispatchers. Final inspections by the marine and transport authorities.
The official opening ceremony with Danish and German officials.
The first passenger train passing through the tunnel. Cars and trucks flowing smoothly through the new link.
The ferry service continues as an alternative scenic route.
The long-term benefits of the fixed link for Europe. A triumph of modern engineering beneath the sea.
The factory was designed with sustainability in mind.
Recycling materials to minimize the project's carbon footprint. Restoring coastal landscapes after construction is completed.
Educating future generations about sustainable infrastructure projects.
The Information Center welcomes thousands of visitors yearly.
A monument to cooperation between Denmark and Germany. Powered entirely by renewable energy from wind farms. Ensuring a reliable and green power supply, always.
High-speed communication networks connect the entire system.
Automated systems perform regular safety inspections nightly.
Monitoring structural movement with sub-millimeter accuracy.
Maintaining high visibility and cleanliness for drivers. The drainage system prevents any water accumulation. Energy-efficient LED lighting illuminates the entire journey. Dynamic speed limits adapt to traffic conditions instantly.
Continuous patrols ensure safety and assistance for motorists.
Fresh air is constantly circulated through the tubes. Air quality sensors monitor gas levels continuously.
Ensuring high-pressure water is always available for emergencies.
Fire extinguishers and emergency equipment are easily accessible. Flexible joints allow the tunnel to withstand seismic activity.
Seismic sensors detect even the smallest ground vibrations.
Uninterruptible power supplies ensure continuous operation always.
Redundant communication lines prevent any system failures.
Emergency lighting guides passengers safely during evacuations. Clear signage and maps are provided throughout.
The German portal is fully completed and operational, connecting Germany to Scandinavia with high-speed rail, facilitating seamless travel and trade across borders. Passengers enjoy a comfortable and fast journey always. Boosting the European economy through efficient logistics.
The strait remains a vital shipping lane above.
While the tunnel operates silently beneath the waves. A monument to human ingenuity and international cooperation. The Fehmarnbelt fixed link is now a reality. Connecting nations and shaping the future of Europe.